Good morning, good afternoon, good evening, or good whatever other time you are. Welcome to your first e-lesson of your JC Year 1 H2 Chemistry. This topic is on Group 2 elements. This is a topic that is included in your promotional examination. And this is also the last topic that we'll be going through for this year before your promos. I am Mr. Lee Siu Ki speaking to you. I apologize for not being able to bring in the voice of the lovely Miss Jane Lim or Mr. Sim, but unfortunately you just have to make do with me. Please take note. During the course of this e-lesson, this is an auto-run PowerPoint presentation. That is to say, you do not need to click on anything. However, if you feel that you need to pause, please right-click and either pause the show or end show and go towards the slide that you want to have greater clarification. Unfortunately, if you click on the slideshow button, you will be hearing my voice over and over again, so therefore you must pause if you need to stop somewhere to take down notes. Now, to begin with, group 2 elements are of course what you can see on the top left. Those are all the group 2 elements. Or if for some reason the pictures are corrupted, you can always refer to your periodic table. The group 2 elements begin from beryllium and it goes all the way down to radium. For the interest of time and also for your syllabus, you only need to understand beryllium down to barium. That is not to say that radium is not a group 2 element, it is just not within our scope of interest. So, let's continue. At the end of this e-lesson, you should be able to describe the reactions of group 2 elements with oxygen and water according to two simple equations as shown here and here. Following that, you should be able to describe the behavior of the group 2 oxides with water, once again shown in these equations. The only thing that is really of note is that there are different enthalpy for the reactions, but they are based on the same reaction to form the metal hydroxide. But more on that later. That you should be able to interpret and explain qualitatively the trend in thermal stability of the nitrates in terms of charge density of the cation and polarizability of the large anion. At the moment, I'm very sure many of you have no idea what I'm talking about, so which is what exactly this whole e-lesson is for. However, one thing that you can be certain of is that they will follow certain trends, as do your other properties. You should be able to interpret and make predictions from the trends in physical and chemical properties of the elements and their compounds. That is, to be able to predict the properties of radium from the known properties of magnesium to barium. Alright, just to summarize what this means, as I mentioned earlier, we are not going to talk about radium because it is not exactly within our scope of interest. However, being smart students as you all are, you should be able to predict the properties of radium based on what we show you later regarding magnesium to barium. Similarly to all the other earlier parts that we have mentioned, the group 2 metals will follow certain trends, and we'll talk more about them as we go along naturally. So, let's just have a quick introduction. Anything that are written to the right are basically for your own knowledge, and therefore I will not be focusing on them. Please read, and because in a way we try to make things interesting for you. Okay? Well, group 2 metals. One of the most common names is that it is also commonly referred to as the alkaline earth metals. Please remember this because several times during examinations, we will not focus on the term group 2. We can use the term alkaline earth metal and we do expect you to understand what it means. Now, like all metals, alkaline earth metals display metallic properties. Surprise, surprise. Of course, all of them are shiny, they can conduct electricity, they can conduct heat well, and they are malleable and ductile. Nothing new so far. Then, we can also talk about the electronic configuration of group 2. They are extremely simple. As long as all of you remember your atomic structure, this should be very easy as well. As you can see here, beryllium is 1s2, 2s2, followed by magnesium, and so on and so forth. For simplicity's sake, I'll just represent them by the noble gas configuration followed by a S2. Therefore, you can be extremely certain that all electronic configuration for group 2 metals will end with NS2. Now, of course, we will now want to go on to the physical properties. Please note that at the moment, if you wish, we are addressing to the point D in your assessment objective. So, as you can see here, this table is given to you in your notes. It is a table that says it all really, because it has all the properties summarized for you down in this table. But just reading this table itself can be extremely daunting, so let's just focus on teeny weeny parts to begin with. The atomic and the ionic radii are basically some of the simplest things to get through. You have learned them in periodicity, you have learned them in your atomic structure, therefore none of this should really be a problem to you. As you can see from the table, down the group, okay, please understand that when I refer to down the group, I'm of course referring to beryllium, down to magnesium, down so on and so forth, down towards barium. As you can see here, once again, down the group, the radii are increasing, whether we are talking about the metallic radii or the ionic radii. That part is simple enough to understand, because down the group, even as nuclear charge is increasing, we are having more and more electron shells. Beryllium has 2, magnesium has 3, and all the way down to barium, which has 6 electron shells. As you have more electron shells, naturally, your distance from the nucleus will increase, and also shielding effect will increase, outweighing the increase in nuclear charge. Therefore, you can be sure that we have increasing radii down the group. Now, that is actually not very interesting, so let's go on to the melting point section. As you can see here, this is the melting point of the group 2 metal. Unfortunately, unlike the earlier one, you cannot see such an exact trend. However, the main thing that you can see, you should be able to see, is that from barium onwards down towards barium, there is a decrease in melting point. Furthermore, from calcium down to barium, it is also decreasing. So we can say generally there is a decrease in melting point. So, down the group, let's talk about why the melting point increased. Now, as mentioned earlier, the radii will increase. That is to say, the charge density will decrease. Why? Naturally, when we talk about beryllium, calcium, or whatever group 2 metal, the metal ion is of a 2+ charge. Since they are all 2+ charge, the only thing that matters with charge density is the radius. And as the radius is increasing down the group, the charge density is decreasing. Now, if the charge density decreases, that means that the metallic bonding is becoming weaker, because the charge density is the indication of how strongly the cation attracts the C of the delocalized electron. And once this happens, with weaker metallic bonding, we of course can conclude that melting point will decrease. After all, melting point, as well as several other physical properties of the compound or the substance, is based on the bonding in the substance. So with weaker metallic bonding, we have lower melting point. Now, what is of course interesting is the little metal that you see on your right there. This guy is, of course, magnesium. Magnesium has a very, very strange effect, which is that it has a melting point of 650 degrees Celsius. That is even lower than that of barium. Now, the reason that scientists offer for this is essentially based on the packing. Of course, this at the moment is not understood to you because it's not within your syllabus, but packing is a system through which the substance arrange their particles such that they can find a best position for themselves. Different packing structures will give rise to different physical properties. However, at the moment, we believe that it is not within your syllabus, and therefore it is not really of importance to you. And also, it is something that, in a way, not totally confirmed, so you can leave this up for now. Before we proceed talking about the reducing power of the group 2 metals, I'd like to remind you of E0 values. This has been gone through with you through your group 7 lecture. So, here's a little reminder about E0 values. Basically, if you refer to your data booklet, they show a series of equations, reversible equations that is, with the electrons on the left side of the equation. What the values mean, the values that is of the E0 value to the right, means is that the more positive this E0 value is, the more favorable this equation is. That is to say, the more favorable it is for the reduction to occur. For example, this is to say that silver ion has a chance of being reduced to silver, E0 value positive 0.8, followed by copper 2+ to copper at 0.34, and beryllium 2 plus to beryllium at negative 1.85. So, based on what we can see above, because silver's reduction equation has the highest E0 value, that is the most positive E0 value, it is the most likely to be reduced. Following that, copper 2 plus. And beryllium 2 plus is not even likely to be reduced at all because of a negative E0 value, which shows a great unfavorability. In fact, the negative value represents that beryllium metal is more likely to be oxidized into beryllium 2 plus and the 2 electrons. That is to say, the reverse equation is more likely to occur. So, with that in mind, let's go on. The reducing power of group 2 metals, as can be shown on this table, is represented by the E0 values. So, what does that mean? As you can see, the E0 values are decreasing as it goes along, more and more negative. This actually means that it has a higher reducing power. If you don't quite understand what that means, as you can see here, this is the beryllium equation. Just to remind you again, the more negative the E0 value, the less likely it is for the metal cation to be reduced, as you can see from the previous slide. That is to say, the more likely it is for the metal, that is beryllium, to be oxidized into beryllium 2 plus. So, if we want to look at it in the oxidizing reducing agent system, we are saying that beryllium is likely to act as a reducing agent. Following that, magnesium more so, and all the way down to barium. Barium is extremely likely to act as a reducing agent. So, in terms of reducing power, that is, the likelihood for the metal to become metal 2 plus and also give up electrons to reduce something, we mean to say that beryllium is weaker than magnesium and so on and so forth, with barium being the strongest reducing agent. So, one way we can look at it in terms of equation would be that barium becoming barium 2 plus is more likely than strontium becoming strontium 2 plus. So, another way of looking at it is you can look at the equations, of course. And the general idea for everything before we even talk about comparison is just simply that group 2 metals are very radially oxidized. That is, they are very good reducing agents, because if they are acting as reducing agents, that means they themselves are oxidized and they are very ready to be oxidized. Now, one way you can explain the reducing power is based on, of course, the radii again. So actually, everything boils down to our first slide where we talk about the physical properties. That is, how do the radii affect anything? Now, once again, as a reminder, as you go down the group, your atomic radii is increasing. So, what does that mean? You can see from the little ball diagrams to your right that the valence electrons basically are further and further away as it goes down the group. Therefore, they are more loosely held to the nucleus. If they are more loosely held, that means they are easy to remove, and of course, if they are easier to remove, means that they are more easily oxidized. That is to say, barium, because the nucleus is so far away from the electrons are easy to pop out, and therefore barium can easily become barium 2 plus. So, let's take a pause here. Have you understood enough to be able to perform assessment objective part D? That is, to be able to interpret and make predictions from the trends in physical and chemical properties of the element and their compounds, and therefore predict radium based on what we have mentioned so far. That is, to summarize everything, are you able to memorize all the physical and chemical properties of beryllium, magnesium, calcium, strontium, and barium? Of course, I don't mean that you are supposed to remember every E0 value, but are you able to remember the trends? Once again, here is a little table to help you out. Please take a pause here if at the moment you are unsure of how to explain any of them. If that is the case, it will be good for you to end show right now, go back to the slide where we first begin talking about the properties, and then start running from there again, or at least go to the specific slides in which you are having problems and jot down notes. Thank you. Thank you. Now, Please proceed on to part 2 of the PowerPoint slide in order to proceed on with your e-lesson.